Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopants, your host for Open Source Directions, and co-hosting with me today is David Charbonneau.
I'm David Charbonneau, and I'm excited to be a co-host for this episode of Open Source Directions. I work at Quansight, and I'm based in Durham, North Carolina.
And joining us today are Saul and Hameer. Saul, you want to introduce yourself? And then Hameer, you can.
Hey, I'm Saul. I work at Quansight as well. I also work on Lab, and I'm based out of Western Massachusetts.
Hi, everyone.
Thanks,
I'm Hameer Abbasi. I work mainly in Quansight Labs on Uarray, PyTorch, and PyData Sparse. I live in Darmstadt, Germany.
Thanks for both of you for joining us. As you can see, Saul and I are here at PyCon today, and Hameer will be joining us tomorrow. So we're very excited about that. But first off, we want to do our headline section. And before we get into all the juicy details about Uarray, so here's some open source headlines from the past couple of weeks. Hameer, you want to take it away?
So I just read this sort of let's say this opinion piece, because it is an opinion piece, but it's very accurate in what it says. So open source may be the future, but very few are writing it. So it talks about how open source has built the foundations for a lot of software out there today, and how still very few companies actually open source their software, or very few pay people to maintain it. I think Quansight is doing great in that.
Very important points. Yeah, thanks, Hameer. Saul, what are your headlines?
So yesterday I sat in at the typing summit at PyCon. That was very cool to hear, both from the folks who work on MyPy, but the other typing packages from Facebook and from Google. And they had some exciting news about the future of typing in Python. And one of the proposals was variadic generics, which would allow you to type NumPy better and functional programming better in Python. And then also some other stuff that would help support NumPy, like integer types, so you could represent the shapes of your functions in the type signature. So that was cool to see. And if you're interested in moving forward on that, they're looking for kind of people to bounce those ideas off of, because not very many of them actually use NumPy in the day-to-day. So,
right. Yeah. It's a very unique intersection.
Yeah.
Those interested in type theory and Python and the scientific stack.
Yeah.
I'm sure we'll touch more on that a bit later. David, what's your headline this week?
I saw this article advocating an approach to managing your data that's generated by the applications that you use, called local first. The authors discussed the pitfalls of the current software as a service environment and propose an alternative built around consistently replicated data types, or CRDTs. It's a fascinating discussion and something that's worth thinking about.
Excellent. For my news this week, I'd like to point everyone to the SymPy version 1.4 release. You can check out what's new in this release from Aaron Muir's blog post over at Quansight Labs. So be sure to check that out. Lots of good new things, including automatic LaTeX rendering inside of Jupyter notebooks and stuff like that. So go for it. At this point, now we're going to talk about Uarray. So Uarray is an array interface object with Python pluggable backends and a multi-dispatch mechanism for defining downstream functions. And we'll get into what exactly all of that means through the course of this episode. Right now, it has about 185 stars on GitHub. And the main developers are here with us, or some of the main developers are with us. So we're just going to go ahead and ask a few questions and learn a little bit more about Uarray.
So Saul and Hameer, can you tell me a bit about why this project was started and what need it fills?
Sure. So this was started kind of a couple intersecting threads that we were seeing. One was our exploration of the mathematics of arrays, which is a mathematical theory that came out of APL, that was formalized by Lenore Mullen like many years ago, 30 years ago. And so it deals with array operations in a strictly kind of algebraic sense. And so when we saw this, we saw, oh, you can actually do a lot of optimizations by looking at your operations like this. But we needed a place to have put these operations in Python so that they would be useful to people and so that people could use them without having to rewrite all their code. And then we also saw the proliferation of all these different ways to execute scientific computing in Python, like PyTorch, TensorFlow, other kind of array compilers like tensor comprehensions. And so this was kind of speaking to this need for users to be able to access all this great emerging technology, but without having to rewrite all their code. So this is kind of the start of the Uarray project, or these kind of two threads. And even internal to Quansight, we had, or internal, but it's public, the XND project, which is also another way to execute your scientific computing. So all of these things led us to try to create kind of a framework to situate these different parts in so that users could be exposed to them more easily.
Anything to add to that? Or no? All right. Well, so are there any alternative projects out there to Uarray right now?
So there are a few actually. There's array function, which is the array function protocol in NumPy, which is like the de facto way of overriding NumPy functions. Mm-hmm. And there is the array ufunc protocol, which is for a similar thing but for a different kind of function in NumPy. And I was motivated by this to simply, create something still there are a lot of functions such as array creation functions which you can't override in these framework. And what if you run into something like dtypes and objects, dtypes and other objects? So Uarray lets you do that. Uarray lets you override arbitrary functions for arbitrary backends, and it lets you define like even creation functions be overridable, which take basically no arguments. So,
sounds very powerful.
Yeah. On that. So to give a little, maybe a little background first. So there's the Uarray project, but really there's kind of three separate GitHub projects there. There's the mathematics of array work, and then the meta-DSL work. So Hameer has mostly been working on the Uarray project, and I've been mostly working on the meta-DSL project. So for that part, which is a little bit lower level, it actually shares a lot with things like SymPy or with like MacroPy to do macro expansion in Python.
So just to clarify, the meta-DSL piece is symbolic representation of operations that conforms to this theoretical mathematics of array model.
Yeah, it lets you express that mathematics of array model.
I see.
Yeah.
And then because it's all expressed symbolically, you can go and backend to different execution models on the backend. Is that kind of the idea?
Yeah, so the meta-DSL is very lazy, or kind of builds up a graph first, whereas I think the Uarray is more imperative. So you just say, hey, I want to execute this code on different backends like Torch or...
and then just to clarify for folks who might not know the terminology, DSL stands for domain specific language.
Yeah.
Right. Okay.
Yeah.
Yep. Great. Oh, that's excellent.
So what technology is it built on?
Uarray is basically, the Uarray GitHub project, which is one of the parts of Uarray, to be clear, is built on the regular Python protocols, such as the descriptor protocol and the functools module. So basically only pure Python. You don't need anything else to run it. But the backends themselves can have different dependencies. So for example, if you have like an XND backend or a Python backend, or like a MOA backend or something like that, that can have dependencies external to Python.
So who started the Uarray project? How did this come into existence?
Well, I think mainly it started with Travis Oliphant, who's started Quansight and also
started many
NumPy and SciPy. And so he was looking at how do we make these frameworks basically keep being relevant the next and 5 to 10 years. And so I introduced him to Lennar Mullen, who worked on the APL, did the APL work and the mathematics work there. And that collaboration, along with Piero Peterson, who's also at Quansight and helped start SciPy, we started working on this. And then David's been helping a lot as well. Who else? Chris has been working recently also on the mathematics of Array.
Last name?
Chris, I don't know if I can pronounce it.
Awesome. Yes.
Thank you.
I know where credits do.
Yeah. Yeah. Anyone else to add, Hameer, on involved people or David?
I think that's all, everyone.
Yeah, so I guess the idea of using different libraries to do a computation while making it easy to just switch out something was Travis's idea. And Saul took the development lead mainly thereafter, and they tried to formalize all of this as a mathematics of array model. And I joined pretty late in the progress, and I came up with this prototype of how it was possible to do it without formalism at first, because formalism takes a long time, and you have to rewrite a lot of stuff. So I came up with a way to basically do things without having to deal with formalism, but still being able to change what does the computation basically for you.
Perfect.
So who is maintaining the project currently?
So there are 3 parts of the project. There is Uarray, which is the backend switching mechanism. That's maintained by me. There's the meta DSL work that allows you to take Python objects and perform or create a graph of operations and perform probably replacements on those. That's Saul. And then there's mathematics of array, which is Christopher Ostrovchov. I'll refer to him as Chris from now on. He's been working mostly on that, and I think Saul and Chris are only recently starting to explore how MOA can be written in MetaDSL, which I think will make it a lot cleaner.
Great. So where are your users and contributors coming from for you?
Yeah, so the sort of the market here is sort of like that of the NumPy ufunc or function protocol kind of work. So it's other array libraries like Xarray or that sort of level who want to be more general in how they're talking about arrays. And then for the MetaDSL work, also it kind of encompasses things like IBIS. If you've used that, it's a way to express pandas operations in a lazy manner. So it's a similar sort of idea, is that it's a general framework to build that kind of library. So we're looking for other people who are building libraries basically to collaborate on these efforts with us.
So it's relatively low level. It's kind of more of a developer-facing tool than a user-facing tool. Like if you wanted to rewrite scikit-learn on top of Uarray to target multiple backends, this would be a mechanism for doing that. But users of scikit-learn wouldn't necessarily need to know or care about Uarray for most things.
Yeah.
Okay.
For most things. I mean, they might need to use Uarray to switch out the backend, but that's the only thing they really need to care about. Right,
exactly. Okay, great.
Is the project participating in any diversity and inclusion efforts?
We thought about adopting the NumFocus code of conduct, but that one is a bit strict in how the responsibilities on both users and the moderators. So for now, since we're a small project and have a small number of maintainers and don't have, NumFocus behind us, for now it has the Rust code of conduct. But in the future, if we were to write a code of conduct, we could theoretically switch.
Yeah, excellent. I mean, it's a great choice especially for the constraints that you have right now. Well, at this point, we're going to go ahead and switch to our ever exciting demo section. So I believe you both have a couple of demos lined up for us here. So I don't know who's
Just
going.
one, actually. We decided to integrate the two.
Excellent. Excellent. Okay. So I believe Saul is going to share his screen, even though he's sitting right next to me. So yeah, go ahead and walk us through here.
So just a quick intro. Here we're going to integrate the Uarray project and MetaDSL, and we can see each of their strengths in this kind of integration. So the Uarray and UNumPy allow you to target different backends like Torch or NumPy or XMD. And MetaDSL provides a way to sort of optimize your code or replace it before executing it. So what we're going to do here is basically have some code. We're going to write it with UNumPy, then we're going to optimize it with MetaDSL, and then execute it again with UNumPy so that we can execute it on different backends. And this is a very preliminary integration. Both projects are moving rather quickly. So this is more of a proof of concept and sort of an idea of how they work together than the production code that you would be using. But if you're interested in this kind of workflow, please reach out and we're happy to work with you on making this useful for you. So first, what we're going to do here is we're going to import Uarray and UNumPy as well as MetaDSL. And we're going to create in MetaDSL an array class and create some different operations, like doing arange, taking the zeros, or creating an array of zeros, summing an array. And then we're going to register each of those with MetaDSL. So this will let us use the UNumPy to build up the cell graph. So here's the example of using it. So we can say Uarray, we can set the backend to this backend we just created. And now we can call these expressions like arange or sum. And what we see is these actually don't execute, these build up like an expression tree. And so if we look at these, we take their string, we see that it's actually preserving the expressions without calling them first. And you might look at this one, for example, and see, oh, if we're summing a bunch of zeros, it's a bit silly to do that computation because we know that that is actually just going to be 0. So let's write, what we're going to do now is write a way to replace summing zeros with 0. So here we define some rules and we say this, we're adding this rule to it. And now we can apply that rule here to the expression. And we see it starts out like this and it ends up like this. And so,
very cool.
Yeah.
Yeah. But it always returns a 2-tuple of, or it can return a 2-tuple. Yeah.
Here, yeah, it's just,
yeah.
Okay. So then what we can do is actually, we can write a little bit of code to then turn that back, call that again in Uarray. So we can execute these expressions in different backends. So here we're executing with NumPy and we get back a NumPy array. And here we're executing with Torch and we get back a Torch array.
Wow.
So the full pipeline again is here we started with UNumPy for the user. So the user would see this API looks pretty normal to them. We can write these simplifications in a pretty generic way and apply them. And then we can then execute that onto different backends like PyTorch or NumPy. Hameer, is there anything that you wanted to add to this description?
No, you were right on there, I think.
Okay.
Spot on.
And so what's interesting here, right, is that you've got a NumPy-like API in UNumPy, and you've got the dispatch going to different backends, which in theory, that would mean that you could use NumPy as the API, but use those backends and even mix and match them when it seems appropriate, instead of having to learn the API for each of them. Unless, of course, you're implementing a backend, right?
Exactly. So that is how it works. So to use it, you just need to know one API, the NumPy API, and here. So it's possible to switch between them. It's possible to do certain computations in one and certain in another. It's possible, given the correct tools, to even not copy over data, just make them views of one another. So it's order of one operation to convert. And yeah, that's part of it. And I think Saul's example also showed it clearly that that, for example, sum of zeros. So you could have like a sum of trillions of items, and you wouldn't be able to do that in memory at all if it was all zeros. But what you could do, this is a simple example, but what you could do in theory is apply reductions to create a very large operation and just get one result out of it, and that would be really, really simple. And it would just compute the part that you wanted. And yeah, you could have a sum of trillions of zeros, which wouldn't be possible theoretically, and you could compute that in order of one time, basically.
So I guess some of my questions are there is there going to be like a library of these transformation rules so that people don't have to write their own? And how do those get in? How do you know which ones to use? And
that's a great question.
Yeah,
I think our roadmap there is first supporting like to support the mathematics of array, which is its own sort of way of looking at array expressions. So in that case, all of these would be transformed into that form and then out of that form. And that form is basically looking at each array as having a shape and an indexing function. And so that would be sort of one pipeline that we're building out. But yeah, that's a great, I think that will have to be kind of like organic as needs come up. How do we organize these?
Yeah. And then I guess my another question I had, are you thinking about things like common sub-expression elimination in terms of when you actually go to compute this stuff, and how do you, is there temporary elimination and that kind of stuff? So
there's this whole range of compiler optimizations that need to be. So this is why part of Hameer, what he's saying is that the Uarray project right now is sort of smaller, right? It's more like executing things eagerly, which is really helpful because this problem is so big and so open-ended.
It's true.
That it's really, we're going to need a lot of collaboration on people on different fronts to build like those kind of compiler optimizations. So that's our hope, is that by at least creating a framework there that we'll be able to collaborate on parts of it. Because it's a lot of work.
And that's a segue if I've ever heard one. So thanks so much for the demo, but why don't we now move over to our roadmap discussion, and we can just kind of chat about what the future of Uarray holds. So all if you want to start from there.
I'm going to close this window here. There we go.
Oh yeah, thank you. You can close this. So like I was saying, the kind of the first roadmap is integrating the work that Chris has been doing with the mathematics of array into the meta-DSL work, so that you can write things with UNumPy and then have conversions there to turn that into the mathematics of array expressions. And then this will allow for a large number of simplifications, so that all of the NumPy operations get turned into this much smaller set of algebraic operations. And then also on that is then basically being able to do, so this was like a very small demo, more of a proof of concept, but to make it useful in it, like for all of the NumPy API, which is rather large, we need a way to convert between sort of the wrapped types, like and the expression tree and the Python types.
I see.
So like if you pass in an int, you don't want to have to first create an array object around that, to add it. So the system of sort of wrapping in a sane way is actually quite a lot of, it seems simple, but it's actually quite a lot of little minutia there.
Yeah, there's a lot of trouble.
Yeah, and so this is things that all of the frameworks have to do, like TensorFlow or PyTorch. Like, they all have to figure out, if I'm adding a 1, users want that to work. TensorFlow,
right.
So there's that kind of work.
And you have to deal with all the coercion and casting issues. Like, that happens right there.
Well, so some of it we can, at least in meta-DSL, we can avoid a little bit because we're not actually executing immediately. We're saying first build this expression graph. So it's a bit about separating those steps. So we're not going to coerce anything at first. We're just going to say, these are the things we have to do, and these are the types that are inside of them. And then later on, you can decide, I want to execute this on TensorFlow. Hameer, I don't know if Hameer's been talking a bit in NumPy about, or seeing how this has been UNumPy could be relevant to NumPy itself. I don't know if you wanted to talk about that.
I would say part of the longer term goals. So this isn't probably short term, but maybe a year or something along those lines, is to get UNumPy itself become something like NumPy. So I'm not sure how many users it will have, but it'll cover the core API and it'll cover like the functions that people execute, and it'll have a reasonable set of backends to choose from. And that's the goal, really.
Do you envision that including things like the linear algebra package, subpackage of NumPy?
So first I want to do the NumPy core functions. So things like that are outside any submodule in NumPy. So something like NumPy.function instead of NumPy.module.function.
Right.
And the second thing would be doing the linear algebra and FFT routines. And after that, let's see, let's hope the users come in.
Right. No, it makes sense. I guess maybe going back, one question I had for you, Sal, just to dive a little deeper. I saw that a lot of the replacement rules were somewhat defined by their type annotation, right? Or there's some type matching, it seems like there. How deep does that go? Can you specify sort of really derived types in that situation? Can you say, like, I want this only to apply to ints that are powers of 2 or ints that are odd or whatever?
The interesting thing is that the type annotations are there. They're not actually used really. Okay, interesting. So the core part of the meta DSL is Python's pretty untyped. Right. So you can have lists of whatever, and you see this even in NumPy API. Like you have these slices, and you can, it's really nice for users because it's very concise. Right. But it's really hard to write replacement rules on that kind of form. Right. So part of the work is taking Python kind of idioms and turning them into like expressions that are not ambiguous. So each expression has one type and only one type. Okay. So you might have an array, and that array might be represented by an integer. You might have an array, and that array might be represented by a NumPy array. Sure. And each of those are actually separate expressions, so they get a separate name. One is like from integer, one is like from NumPy array. So then in the expression tree, you don't have to do any work to say, oh, what type is this? Like the type is explicit in there. If that makes sense. Yeah, that makes sense. But like, I guess my question was kind of more about having rules that specifically target certain derived types, or is that just something that you implement in the function body itself? Yeah, that's something you'd implement. There are the difference between sort of the pure rules, which are just you're moving nodes around, and then the ones that are more like check if this int is greater than 5, and if so, apply this rule. Right. So if they're pure, there is more of a chance to do optimizations, like to make the replacement quicker, right, by smushing them together. If they're more just like random Python functions, those are still supported, but you have less of a chance to optimize how those are replaced. Understood. Right. Understood. Okay. All right. Cool. Is there anything else on the roadmap here that you'd like to ask?
So I'm not sure. I think I've been looking at JAX lately, and I think JAX backend seems nice, actually. Can you
describe JAX in one sentence for
basically NumPy by Google, but JITted.
But shitted, okay.
Yeah. And
nice.
It's by jitting it. I mean, it builds up an expression tree and kind of does the reduction in itself. It's kind of it has a nice interface already, but I'm not sure. It depends on what the demand is by people. Is this something is this backend useful to them, or why is this function missing from this backend? And I think we need to let the users drive what the need is.
Okay, yeah, sounds good. Saul, anything else?
I just had a comment. I think Hameer briefly mentioned like one thing that Uarray and UNumPy is very useful for is that currently there are these array overloading mechanisms in NumPy, like to override certain functions, but you can't override, for example, a range or zeros.
Right.
And this is just not in scope right now for what NumPy allows.
Right.
And so this is what sort of why Uarray and UNumPy need to exist somewhat, because it will allow you to override those kind of functions.
Right.
Mm-hmm. So that's one thing I actually wanted to mention related to that. So NumPy only allows overrides on one thing, arrays right now. And in theory, what you could do is define a different type of shape object and override on that in UNumPy. I know it sounds strange, but it can be useful because Dask could have their own shape object. Xarray could have a shape object that has, for example, I don't know, dimension names in addition to the number that's in the dimension. So it could be a dictionary instead of a tuple. And you could override on ufunc objects. So it becomes ridiculously easy to define new ufuncs, UNumPy ufuncs, not traditional NumPy ufuncs, to be clear, but it becomes ridiculously easy to define UNumPy ufuncs.
Right, which is a pain point in NumPy right now, for sure.
Exactly.
Yeah, no, those are all really good use cases.
And the third thing that would be useful for is actually, defining dtypes, new dtypes. And defining new dtypes is actually a really, really big pain point, because when you define a dtype, you have this big structure inside NumPy, which is called the big array function structure so far. And the problem is each time you want to define a new core dtype, you have to edit that structure. Basically, it's a bit of I don't want to get into CS here, but it breaks everything that was compiled before the change happened if you release a new function with that. And I think adding dtypes will be easier with UNumPy.
Right. Yeah, that makes sense. So I would like to emphasize at this point, these are all places where Uarray or the various parts of the Uarray project are looking for help and contributions and funding. So if any of these ideas sound interesting to you or exciting to you, please, come and reach out and help. These are all open source. I believe they're all BSD licensed. I might be wrong about that.
BSD3, yes.
Yeah, BSD3, yeah. So, come and help out your array either with funds on these roadmap items or other ones, or just if you have thoughts. And frankly, it sounds like even if you wanted to be kind of a early stage tester, that would be really helpful, right? So
that would be the most helpful, actually. All parts of the project.
Right, and report back what's not working. So,
or what you need, right?
Or what you need. Yeah, that's another great point. Yeah, thanks. David, do you have any other questions or comments on the roadmap specifically?
I don't. Maybe we should get to some user questions. We've got a couple.
Yeah, I think that would be really great. So the first question for you, it comes from Piaru, who asks, who will be the end users of the Uarray tools?
The end users.
That's the question.
So if things go as planned, then probably data scientists or academics, numerical computation experts, and probably for MetaDSL. This is for UNumPy and USciPy and the U science of libraries. For Uarray, I believe it's anyone basically who wants to swap out an implementation for another. And I think Saul can talk about who he wants the users of MetaDSL to be.
Well, yeah, and I think so. One of the historical trends we're looking at is the end of Moore's law and the increase of different kinds of heterogeneous hardware, like GPUs, but also TPUs or ASICs, FPGAs. And so as these devices come online and users want to start accessing them, they need software pipelines basically to get there from their existing tools. So that the target here is people who, even like Dask, for example, right, is doing distributed array computing. So it's for folks who have some scientific computing in Python, but want to use it on a different kind of computation platform.
Right. Yeah. There's a lot of different platforms that people can target these days.
Yeah.
There are.
We don't need to recount them all right now. I think we have another couple of questions here. David, if you want to take the next one.
Sure. Ivan Ogasawara asks, is there documentation that explains how to create a Uarray backend?
There is actually. There's a simple notebook. I can link it in a bit. So hold on.
Well, we'll get to that notebook in a moment, but I think we'll link it. We'll put it in the show notes, and there is documentation. Probably feedback on how good that documentation is also very welcome. So yeah. A great question. Thanks, Ivan. I think that might be our first real documentation question in the whole series. So congrats to you. I should give you a sticker or something. Our next question comes from Joseph, who asks, can you talk a bit about how Uarray rates to NEP 18 or the NumPy enhancement proposal 18? And this one deals with the array function protocol. So this is getting into the weeds a bit, but hopefully you guys can speak to that somewhat.
So like I said, NumPy array function protocol solves a part of the problem. It doesn't solve all of the problem. Uarray is pretty new and has the potential to at least solve a larger part of the problem, I think.
Can you be a little more specific in terms of what the parts it is and isn't solving? I mean, I think my takeaway was that it's not solving the array creation problem necessarily. It only works once you have an array, and this helps solve the array creation.
Once you put an array into a function, that's when it works. And you can only override on one kind of thing, an array. You cannot override on a dtype. You cannot override on, array ufunc lets you override existing ufuncs, but creating ufuncs is still hard. You cannot override on shapes, which is what maybe Xarray would want. And the second problem is coercion. How do you transition seamlessly between backends? Because it only lets you, once you have something, that it automatically defaults to NumPy. That's one of its, actually, I would consider its weaknesses. But Uarray lets you choose, right? Uarray lets you choose, hey, I want this to be the default. I want maybe a different default. I want maybe to dispatch over these arbitrary objects to a different backend and force that backend. So NumPy array function is no way of forcing a backend currently.
Yeah. Now, some of those backends, I can imagine coercion will be somewhat difficult, or it'll still be expensive, for example, to send things to a GPU no matter what you do, if the data is if the data is in main memory. But at least this will work.
About that. No magic. Except for maybe PCIe 4, which is a completely different topic.
Well, maybe we'll do that webinar in September sometime. No, I'm teasing.
Hameer, I had a question on that. Does Uarray use NumPy? Does it implement the array function protocol?
No, Uarray currently does not do any kind of. So currently, Uarray does not do any kind of array function protocol, but there could be. It would be pretty easy to develop a backend that just used array ufunc for everything. That would be definitely possible.
Sounds like a potential roadmap or location item for people to contribute to if that's what they're interested, or maybe Ivan, since he's eager to start writing backends here. All right. Well, I think that's all the questions we have at the moment. So thanks. And it is now time for our world famous rant section, where each of our panelists here gets a 15-second slot to rant about whatever topic they want. Saul, it is your soapbox.
Yeah. So I was just thinking, what do I want to rant about in the open source world? There's a lot you could rant about, but I was also just thinking about what I love about it, and it's all the wonderful people that I get to work with, and also just sort of diverse, not necessarily, based on their, gender or anything like that, but more so like where they are located in the world, what company they work at, what kind of tools they work on, what they care about. So yeah, my rant is just I'm grateful to be able to be a part of this ecosystem.
You're here.
My rant was a bit off topic. I can't find a dish consisting of both potatoes and strawberries anywhere.
Yeah, that's a rant for sure. Yeah. Send that to the Food Network. David, it is your soapbox now. Strawberry box.
Mine is there's someone on Twitter I follow that goes by the name of Monoid Mary, and she's got a lot of interests and she posts about a lot of things that are interesting to me, like Haskell and category theory, just software development in general. But she's taken a break from a couple of different communities on the internet, including Twitter, and I don't know the details of what is going on, but it seems that there are dudes on the internet that are responsible through their treatment or how they respond to her, and I have this to say to the dudes responsible: because you've deprived me of her wit and insight. Screw you. Really, just stop it. And to the friends of dudes that are responsible for this kind of problem in general, because it's not like this is a singular person on the internet experiencing this. This is a lot of us, especially in the open source community. If you don't speak up, if you don't shame these dudes, you're complicit, and screw you too.
Yeah, it's very sad to hear. And I completely agree. For my rant today, I would like to move in a little more positive note and just say that PyCon is a magical space, and it's wonderful to be able to see all of my old friends and to be able to meet a bunch of new ones as well. So that's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you are interested in funding open source projects, including Uarray, you can find all of the project roadmaps at quansight.com/projects. Saul, where can people find you and Uarray?
I think GitHub is probably the best place, but also feel free to reach out to Hameer and I individually. Since these are new projects, we would love to chat more in depth with you if you have questions.
And Hameer, where can folks find you? Same place.
Abbasi at Quansight.com is my email. Hameer Abbasi is my Twitter and GitHub handle. And yeah, just feel free to get in touch.
Excellent. Well, join us again next episode when we kick it up to 11 for a discussion about X-Tensor. All right. Bye, everybody.
Bye.